Hi everyone, we're going to talk a little bit about probability theory in this video. You should have already read over the slides before you watch the video, so I'm going to go a little quicker through the slides that you should have read on your own, and we'll work through the examples that aren't filled in. Okay. So we're interested in probability. This tells us what we can expect to happen if we were to do an experiment in a very long series of repetitions. So if I were to flip a coin hundreds of thousands of times, I would expect half of those flips to be heads and half to be tails, for example. So remember, a sample space is the set of all outcomes in an experiment. So if I were to choose a student and determine the student's gender, well, you could be male or female, so that's my sample space. What if instead I wanted to know their class rank? Well, the possible class ranks are freshman, sophomore, junior, and senior. So that's my sample space. Notice that it's the question that determines the sample space. So if I asked you what are the possible sequences of hits and misses if a basketball player shoots a free throw, well, one way we could do this is to draw a tree diagram. And there you can see the list of sequences of hits or misses. There are 8 of them that you need to list in your sample space. If instead I asked you how many baskets they made, that's a different question. So here my sample space is 0, 1, 2, 3. You could make no baskets, 1, 2, or all 3 baskets. Your sample space could consist of infinitely many things. So here if a mouse is trying to finish a maze, it's possible, a rat, it's possible that the rat could take any number of minutes to do that. And so here our sample space is all the numbers between 0 up to infinity. Let's try finding the sample space for these experiments. So, this first one asks you for the sequence of birth orders if a family has 3 children. Go ahead and take a minute, try to draw the tree diagram for this. You can pause the video, and when you come back, we'll look at the sample space. Okay, so if you've made your tree diagram, the outcomes you should have gotten are boy, boy, boy. They could have all boys. Boy, boy, girl. Boy, girl, boy. Boy, girl, girl. Girl, boy, boy. Girl, boy, girl. Whoops. Girl, girl, boy. And girl, girl, girl. So there are 8 possible outcomes here. What about if we roll 2 6-sided dice and observe the pair of numbers showing on the faces? So here think in terms of your slot diagrams to think of how big this would be. There are 6 possibilities for the first die and 6 for the second die, so we'll have 6 times 6 or 36 possible outcomes. And you can write them as an ordered pair, so 1, 1 means the first die has a 1, say the red die, and the green die also has a 1. We could have a 1, 2, a 1, 3, and so on. I'll let you fill this in, up to 5, 6, and 6, 6. So again, there should be 36 total outcomes. What if instead of recording the 2 faces, I just record the sum? Well, this is a different question. And here, the possible sums, we look at what could happen if I add the 2 faces. Well, if I add a 1 and a 1, I could get a 2. If I add a 1 and a 2, I could get a 3. I could also get 4, 5, 6, 7, 8, 9, 10, 11, 12. Can I get anything bigger than 12? No, the biggest number is a 6 on the die, and so 2 6s give you 12. So that's my sample space there. Okay, an event is just a subset of the sample space. I'll let you read the top example and we'll work through the bottom example. So the event that a sum of 5 occurs on a pair of dice is a subset of the sample space. So here, this was our second sample space. How could we get a sum of 5? Well, I could get a 1 and a 4, or I could roll a 2 and a 3, or a 3 and a 2, or a 4 and a 1. Whoops, and this is not my sample space. This is a subset of my sample space. It's an event. The probability of an outcome is always going to be a number between 0 and 1. And if we add up all the probabilities of outcomes in a sample space, they must add up to 1. We write P of E for the probability of an event, and that's just the sum of the probabilities of outcomes in E. I'll let you read the example below. And this example, again, this is the problem with 3 children, and we've recorded how many girls they have now. And again, you can read this example. Notice that here, the probability of severe side effects is just the number of times that you observed severe side effects divided by the number of times they did the experiment. Let's try this one together. So we have the marital status of men and women in the U.S. If we randomly pick a male, what's the probability that he is divorced? Well, the probability that a male is divorced will be the number of times let's say the number of divorced responses divided by the total number, I should say male divorced, of male responses to this survey. Okay, so that's going to be 10,818 for the number that were divorced. That's this number here. And the total number, I need to add up all of the numbers in the male column. So 60,955 plus 2,908 plus 10,818 plus 210 plus 3,943.5. Okay, so go ahead and plug that into your calculator. I'll plug it into mine. Ten eight one eight over 116,326. And that gives me an answer of 0.093. So the probability that a male is divorced is 0.093. Okay, this is probabilities based on empirical data, the result of an experimental data. In this case, the probability is always the number of times E occurs divided by the total number of times the experiment is performed. So on the last slide, it was the number of times we got a divorced answer divided by the total number of male responses. Probabilities could also be based on theoretical information, namely combination formulas, the formulas that we were using last time to count different things. Okay, so we flip 3 fair coins and record the sequence of faces up. What's the probability of each outcome in this sample space? Well, first of all, what's my sample space? If I record the sequence of faces up, I could get heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, or all tails. Okay, so there are 8 possible outcomes. What's the probability of each outcome here? Well, when I flip a fair coin, it's fair, so each face has an equal chance of being face up, and so each of these outcomes is equally likely. Since there are 8 total outcomes, and I know that the sum of the probabilities of each has to add up to 1, the probability of each outcome is going to be 1/8. Okay, so for example, the probability of all 3 coins being heads is 1/8. All right, why don't you go ahead and try number 2. If you have questions, you can always email me over the weekend. Thanks for watching, and again, please email me with any questions.